Thank you. And welcome back from lunch. Hopefully everybody's awake and ready for the next talk. Who am I? My name is Aaron Jewitt und ich bin in Deutschland seit 7 Jahren, aber I'm going to do the talk in English because I never worked in German. I've always worked in English, and I learned German from my kids and from the beer garden, so it's probably not appropriate for the work environment and on the stage. So there's my information. Little background about me. I've been in cybersecurity type roles for over 20 years now. I got started at the NSA on the what we're going to call the red team side at TAO. Did that for about 12 years, and for the last 7 years, I've been doing threat hunting and detection engineering, with the last 4 of it being with Elastic. I'm on the Elastic InfoSec team, so my job is to protect Elastic and try to keep our workforce safe. Here's the agenda of the talk. We're going to talk about what is real-world detection engineering, protecting a distributed workforce. Then we're going to pivot a bit to talk about the dangers of the cloud and how you detect attacks to the cloud. Because if you are a remote workforce, you're going to be using cloud resources, et cetera. So let's kind of go in. What do I mean by real-world detection engineering? Quick, in case anybody's not familiar, detection engineering is a fairly new role, and basically detection engineer writes a query that is designed to catch an action, or catch a hacker or somebody doing something bad, and then fire an alert when you see this query. And then there are 3 different types of real-world detection engineers. And I'm lucky at Elastic because we're a security company, so we have all 3 types working within our company. You've got the product type security detection engineers. We've got our team lead here, Justin. He'll be talking tomorrow about that. Maybe not about that, but about other things. They're focused on creating detection rules that are very focused towards catching malware, but not for having false positives. Because if you sell a product and it just goes nuts with false positives, people are just going to turn it off and complain and want their money back. So they're very, very concerned about that. Then you've got the threat intelligence company type of detection engineers. They're following a threat actor, they're publishing IOCs, and they say, this actor did this thing, and here are some detection rules to catch it. And usually these are these are very overly broad. If you try to plug them into your own network, it'll just go nuts. It'll make it'll be louder than my family is on a Sunday in Ruhetag. Sorry, German joke. I get yelled at all the time. We're the loud American family. I have 3 teenage boys. And then the detection engineers, the real-world detection engineers, this is what I do. This is the most common type of detection engineer. Most of the people in this got started out as a SOC analyst that was just tired of having too many alerts, or maybe the red team came in and you didn't detect the red team and you said, we can do better. And then you start building custom detection rules. That's how the field of detection engineering got started. And the real world is very messy. It's not, the default rules just don't work in the real world. They're going to go nuts, it's going to make noise, and it's going to miss things too. And you get blamed by the SOC analysts if the rules are too noisy, and you get blamed if they're too quiet. Why is the real world messy? You got limited resources. Security is often second to business needs. You got to make a profit if you want to stay as a company. API keys, tokens, identity management is hard. There's shadow IT everywhere, people standing up servers and not telling you about it. Large giant customers with one-off weird, requirements that you have to maintain legacy architecture way beyond its lifeline. All of these things. And software updates run by, Lenovo, Dell, HP. All of these updates always trigger our alerts, and they're always noisy because the updates pretend to be a hacker, or the hackers pretend to be updates. I don't know which one it is. Sometimes it gets a bit mixed up. And all of your third-party providers, the logs are different. It's just so many different technologies that you have to understand. And so how do you kind of clean up this mess? How do you manage this mess? So these are my core principles for detection engineering, and within a SOC, within a real world. Actionable, focused. You have to provide content, and you have to keep trying to get to that 0 false positives. So we're going to kind of go into each one of these. What do I mean by actionable? This means that if you take an alert and you show it to a human being, they need to be able to do something with that alert. if you've got an alert for something, but there's no policy saying that's not allowed in your network, and the SOC analysts just start to ignore that alert. They can't do anything about it. If you send an alert and if you can't take an action, it gets ignored. And if it gets ignored, then you're going to miss the red team or worse. And so if you have an alert that you can't take an action on, maybe drop the severity or turn it off completely. Document the risk. Get your CISO to sign off to say, we accept this risk because we won't make this behavior change in our network, so we have to turn off this detection rule. I mean, these are the trade-offs that you have to do because if you have an alert that's not actionable, it will get ignored, and it's worse than worthless. Your rules should be tightly focused. I've seen too many bad detection rules where they try to do too much with everything. You get a rule that's trying to detect everything all at once, and when the alarm goes off, it's either going off all the time because it's hard to tune, or the analysts have no idea what caused it to go off. So don't make one rule when you can do two, don't make two when you can do four, etc. The rules don't really cost you much, a little bit of management overhead, but that's about it. So keep your rules as tightly focused as possible. Context is key with all of you. Anytime anybody working in a SOC, anybody who's been there a while has had those alerts where it says something bad happened. Okay, cool, what happened? And in order to find out what happened, you've got to stop what you're doing, go dig into these logs, go look things up. You've got to take all the context and put it in front of the human. If you're willing to get their attention, then you need to automate all of this effort to get this context. Provide all the information from the alert. If it's a processed alert, show the parent processes, show the owner, show the system. I'm going to get in later about how we use our asset database. We enrich all of our alerts, so we have the system owners all in a database. And so we can say, okay, this alert is owned by this user. This user is a member of this cost center, because we have our HR records in there as well. So now when I see mimikatz.exe getting run, if it was a member of Justin's team, I can say, okay, it was probably somebody doing research. But if they were a member of accounts payable in our HR department, I get very concerned, and we respond in a much different fashion. That context that you put in front of the people, that is absolutely key to fast response. And I'm going to get into that with the cloud. You have to up your speed. If you're a SOC analyst, you have to respond faster if you want to have any chance these days of stopping the attackers. You're never going to have zero false positives, but it doesn't mean you shouldn't try. Sorry for any 80s kids where if that meme triggers some bad memories. I guess we'll stick with the retro theme. If you're too young for that, that's from The Never-Ending Story. It's a great movie, especially if you have kids. Go watch it with them, especially if they love horses. Don't worry, the horse is alive at the end of the movie. Spoiler. So every week, if you're a detection engineer, or even if you're just a SOC analyst, and say you're in a smaller SOC and you don't have a detection engineer dedicated to it, every Monday, look at your last weeks of data, and look at the top 5 noisiest alerts and tune them. Get them so that they're not noisy. And maybe you don't have time for more than that, but just doing that every single week, and you will progress towards that zero false positive. And you're never going to achieve it, because even if you get everything perfectly tuned, then your Lenovo laptops are all going to push out some crazy update that's going to look like malware and fire off all your alerts. Somebody's going to deploy some new software. It's going to happen, but you can't give in to the sadness. You got to keep trying. So now I'm going to talk about the thing I actually told you I was going to talk about, protecting a distributed workforce. And what do I mean by distributed? Well, at Elastic, we started as an open source, it was an open source project started by 4 people spread around the world. And they said, you know what? We can just live where we live and work on this project, and let's build a company around that. So for the last 10 years, Elastic has been a globally distributed company. We have some offices, but they're basically co-working spaces with good Wi-Fi and an even better free snack bar. And that's about it. You don't actually get anything from going into this office. You don't connect to the LAN. There are no file shares. You don't have special privileges. You don't get behind the firewall. There's none of that. And so how do you protect this workforce? We're in 42 countries, 20,000 people, or 2,000 people. We use cloud-native applications, all of these third-party systems. It's it's a very complex thing, but it's actually, I prefer it because there's some certain big advantages to it, like we don't have Active Directory, we don't have any Exchange servers, that's great. All of this stuff. We collect a lot of data. Some of that's because we are also a cloud provider, or we're a cloud SaaS provider. So that's a big chunk of our data. So don't get intimidated by that, these big numbers thinking that would be everybody. A lot of that's from our cloud data. So how do you monitor, protect a distributed company? And this applies for all as everybody's working from home now and working distributed, most of these apply to you whether you realize it or not. This is pretty much everything on one slide, so that you can take a picture and leave if you want. This is the talk. Just kidding, don't leave. Let's go step through some of these. Why do I have this as number one? Because identity is the perimeter. When you're a distributed company, identity is your perimeter. It's not the firewall. It's not the gateway. Those things don't exist anymore. And let's be honest, they were never really the perimeter. It was always identity. The hackers, they usually didn't work from your office. They worked remote, and they would log in from a remote office. They were remote workers you didn't pay until the end. How do you stop that? You have to do FIDO2 MFA. What do I mean by FIDO2? We're talking the biometrics, YubiKeys, Windows Hello. Why is this important? Because evil NGINX, that's the little logo there, and other things, they can proxy any of your MFA logins, that involve like a one-time code or an SMS is even worse, but the one-time codes, things like that, they can all be proxied through evil NGINX. And when I say proxied, I mean the user sees your corporate login. They see their photo, they see everything looks exactly like the corporate login. They have the little green SSL lock icon on the top. It looks perfect, except they're logging in through the attacker's site to proxy, and the attacker steals their session token. Once they have that session token, they can do everything as that user. Evil NGINX, you can go and set it up on your own. If you're too lazy for that, they have a service where you can just go to their cloud service and use their proxies. I think it's like 100 or something a month. So it's a pretty low bar of entry to phish that. And so why is FIDO2 protected from that? Because it does certificate pinning. So that when I set up the fingerprint sensor on my Mac and I use my fingerprint to do the MFA authentication, it does a full end-to-end encryption with a certificate pinning to my company's SSO. So it can't be proxied, it can't be redirected to somebody else, they can't steal that fingerprint session. And so Windows, like I said, Windows Hello, iOS, there are a lot of different ways. There are always going to be edge cases, there are always going to be users with reasons why they can't do it, but it's worth pushing to try to get everybody on this. Now, even once you get everybody on this, it's still not foolproof, because the session token is just a cookie. And so when you're talking about the traditional ways that people would attack a network, they would get onto your Windows system, they'd run NetView, they'd start moving laterally within the network. Well, now when an attacker gets on a workstation, let's say they get on a workstation through malware, they're going to try to steal those session tokens, which are going to be, they're just cookies in your browser usually. There's clear text strings that they can be stolen. So you have to protect those, set maximum lifetimes to them, watch for anything that's grabbing cookies that shouldn't be. Use a managed browser with controlled extensions and plugins if you can. And then any of your absolutely critical applications, use step-up authentication. So like our SIEM, every time I log into my SIEM, even if I just logged into our SSO, it requires me to do my fingerprint again. Because even if somebody steals my session token, they try to go and use it on my SIEM, it's going to say, no, we need a fingerprint for this. For our cloud console, all of these critical infrastructure, you have to do that. Now, how do you manage all of this from a distributed point of view from a SOC? Well, we put all of our data in the SIEM. And when I say all of the data, I mean all of the data. We're not just looking for security alerts. We're not just looking for endpoint, protection, firewall, things like that. We've got all of our server systems. We've got AuditBeat, getting all of the process information, all of our observability data, all of our third-party processes, our HR systems. We pull in audit logs from that. We have our asset database. I'm going to go into that. That's amazing to have in there, so because you can do enrichment and everything. We even have our malware sandbox plugged in, because now I can execute malware on a VM. The data goes into my cluster with all of my production rules, and we can say, hey, will this set off my rules? I can test my rules like that. And that's all just built in like this. And so we use cross-cluster search. It's an elastic thing where you can have these clusters, and then you have one central cluster, which we use for our SIEM, and it doesn't actually contain any data of its own, but it has visibility to run, it has the ability to run queries on all of the other remote clusters. And this helps us because, like I said, we have observability data. So our ops teams, they want to have access to that. We have HR data. We give our HR team access to that so they can run reports and do all that stuff. And then we can query everything without giving them access to everything. When you put all of your data in the SIEM, you have to standardize your field names. If you want to do investigations, you want to do alerts. Everybody that's been working for a while in the SOC has run into this. When you're looking at logs, you run into all these different field names. You have to standardize it, so then I can search for source.ip across all of my data sets at once with a single query, and it'll show me everywhere that IP address showed up. And this is, like I said, the attackers are moving quickly now. You have to move at their speed. And you can't do that if you have to run 15 different queries in order to change all your data. We use Elastic Common Schema because out of the box it just works if you're using FileBeat or our integrations. They just recently joined with OpenTelemetry, so those are all linked together. I don't really care if you use that or something else, just standardize it. And then automation, because once again, you don't have time to do all of this manually. You take the alerts from your SIEM, you get it out. It's all webhooks and APIs. And I'm going to go in a little bit later with some of the cool stuff we've been building. But you can link all of this stuff together, and you can work with your OpenCTI or your MISP or your threat intelligence, take the data in your SIEM, look at the alerts, send alerts to PagerDuty or to Slack, whatever. It's amazing all of the stuff you can build out. If you spend a little bit of time on that, it'll save you hours and hours later on. And automate everything. And so there are different levels of automation. There's alert enrichment, where you can take an alert. You're not actually automating anything, but you're going out to all sorts of other data sources and providing context to the analysts when they get the alert. And so this is an example of what our alerts look like in Slack when they hit. And so we take all the context from the alert, the process name, the parent process, the user, the host name, all that. But then we also go out and we say, I've got the host name. Let me check the asset inventory, and let me get the owner of the system, and let me get their Slack information and their phone number. Let me get the workday information so I can tell you what time zone they normally work in, where do they live, what department do they work for, all of this information. I've got the host name, I've got the username. I'm going to go back to my SIEM and run a query and say, show me all alerts over the last 7 days for this host name. Show me all the alerts over the last 7 days for this username. And then add those as threads to the Slack alert so that it doesn't clog everything up. So now when I'm like on my phone at the store, if an alert goes off, I don't have to run home, open up my laptop to see if it was maybe something bad. I've got all the context right in front of me to make a decision whether I can finish my shopping or if I have to go home. That's the power of enrichment. Distribution of alerts takes that a step further, where you say, okay, an MFA device was added to this Okta account. I can send that directly to the user and say, hey, did you just add this, yes or no? And if they say yes, then it closes the alert. If they say no, then it opens a case, it adds people to the case, it escalates, all of that. And so we have the system owners, we can build all of that stuff out. OS query commands, that's one of the awesome ones that we can do stack native. So in Elastic, we can say, after this alert fires, run this OS query pack. And so when we see a malware alert, we have a OS query. If you're not familiar, it's basically you can run queries on your workstations and get answers, and it's very, very powerful. You can get all the running processes. You can get the memory information of all the running processes, environment variables, installed applications, installed processes, registry, file. We get all of this stuff. We do a full forensic investigation within seconds of your malware alert being triggered. And that gets added to the stack. Why? Because I'm sitting here in Germany. We have employees all over the world. If somebody's in Japan and a malware alert triggers, when I wake up to review the alert, it could be several hours after that alert triggered. And so now I'm going to have all of the context from within seconds of it, within seconds of that alert happening. You can even go, if you're really crazy, you can go and so far as to start, automatically quarantining cloud VMs, making changes to your cloud systems depending on how confident you are in an alert. And once again, you don't have time to triage everything. Automate everything you can, distribute it if you can. If you can't automate it, maybe you can enrich it. If you can't do any of that stuff and it's just too noisy, then maybe set it to low, because you can write alerts on your alerts. Alerts are just data too. You can then, once you've got these alerts sitting in your SIEM, you can say, hey, if this alert belongs to somebody who's a member of our SRE group or a member of our domain administrators group, elevate it, bring it back up. This was a low alert, but this fired on their system, so now it's a high alert. You can do all of that stuff. The new terms rules, those are one of the newer features where you can say, hey, here's a term that hasn't been seen in the last X number of days. And so that one's pretty cool for us. We've got a rule, so we say, okay, if this alert is first time triggering and it hasn't been triggered in 30 days, then fire a new alert, make it a higher priority. Because even if it's a low priority alert, the fact that it hasn't done anything and it's been quiet for 30 days, that's a bit weird to me. It's not regularly a noisy alert, so maybe somebody should that's more of a threat hunting thing at that point. Asset inventory, everybody's least favorite thing to do in InfoSec. I know you came to a detection talk and you're like, what, this is asset inventory. I don't want to talk about that, that's boring. But it's very, very important. And I'm not here to talk to you so much about how to build the asset inventory, because my colleague Laura built it and I didn't, so I can't actually tell you about how we built that. She's written some blog posts and done some talks recently about how we've built this asset inventory database within Elastic. I'll go to the very high level, and basically what they did is they built a data model where they said, we have entities within the company. What is an entity? It's a computer, it's a human being, it's an office building, it's a network zone inside of your cloud. These are different entities that I'm interested in. And then they take all of them, they do some data modeling, our security architecture team, they wrote some nice custom scripts to go out every day and scrape this. So every day they get all of our GitHub users and all of their information. They get all of the HR system, all of the cloud assets from Azure, GCP, AWS. If you have Active Directory, you can do the same thing. You can get the computers, get the users, all of that information. And then they ingest it into the Elastic Stack, into a single in a single index pattern that I can then use to build detection rules on, to build enrichment on, and do all sorts of amazing things. And you'll see later like some of the really cool stuff we started doing with this. I guess I've got this right now to talk about some of the detection rules we're doing. So the indicator match rules, the top one, real quick on that, an indicator match rule was designed to be something where you'd have a threat intel feed, like say your MISP, and all your IOCs are coming in from MISP, and it's just doing a join to say, okay, if this process hash is seen in both index patterns, then fire an alert. But what we found is that you can say, okay, I have an alert, and here's the username. Now run a query over here for everybody who's a domain administrator. And if the usernames match, fire a new alert. And so all of these different things, if it's critical asset, all of the stuff that we've done to get this database into our SIEM, we can now fire these new alerts based on the severity of the events. Oh yeah, that last one, outside of specific teams, we actually caught the red team with that. Fun story, we said, okay, I was just testing this out. I said, okay, if anybody who's not on my team starts cloning my repo, send me an alert. And then with, a few days later when we were doing a red team event, I caught them. I was like, hey, there we go, that worked. And so there's all sorts of really cool things you can do. And if we didn't have the asset inventory, we couldn't have done that. So an example of the enrichment, this is kind of like, this is what gets added to our alerts. So this is my information if you wanted it. Like I said, Germany, I live up by Frankfurt. So yeah, we've got the last Okta login, Okta status. That one's great because one of the common problems in a SOC and in security is how do you detect if somebody, say a terminated employee, but they've got a backdoor to the system or they've got an account that didn't get terminated. With this, I can say, hey, I've got a username, I've got a system owner, I've got this laptop, and I can enrich it and say, their Okta status is deactivated. Why are they active? Why are they doing this? And so lots of cool capabilities with that. Jamf, that's what we use to manage our Macs. So we have a list of, you can see I've got 2 Macs sitting on my desk at home. You can use all of this stuff to enrich it. Intune we use for our Windows systems. So that's kind of how we're managing and protecting the distributed workforce. Some people would call it zero trust. I don't like that because everybody's got to trust somebody. And you're going to see that in the cloud, like the dangers of these chains of trust and how bad it is. But in effect, the way some people ask me about like what is zero trust, how do you define that? If you can take one of your employees, hand them a Chromebook, and they can do 90% of their work, or even all of their work, then that's pretty much zero trust at that point. And that's pretty much where we're at and the mentality we've had from the beginning at Elastic. So dangers in the cloud. What is the cloud? Linux servers, somebody else's computer. It's a big mess of infrastructure as code. It is the fastest way to give your money to Amazon or Microsoft or Google. And it's all controlled with APIs that use single-factor authentication. There's no MFA inside the cloud. There's MFA to get into it, but once you're inside, it's all just, strings of text says I'm good. It's a bit scary. Oh, and the technology changes constantly, and nobody really understands all of it because it's so complex. So I hope that gives you a nice warm and fuzzy feeling about everything. So from a detection engineering point of view, what are the 3 biggest challenges in the cloud? The scale of the attacks, the speed of the attacks, and then the complexity of the environment, and you can call it the attack surface that I'm in charge of protecting and building these detections on. And so what do I mean by the scale of attacks? Like I said, we're a SaaS provider, so we have Elastic Cloud where you can go in and spin up your own Elasticsearch clusters. We manage it, I protect it, all of this stuff, and it's all on AWS, Azure, GCP. This is a snapshot from 1 hour this week. So during that 1 hour time period, we had 55,000 deployments. That's 55,000 Elasticsearch clusters running in Elastic Cloud. Over 500,000 containers were running. Every single container is an exploitable endpoint. I mean, a container runs code in it. That's something that an attacker could exploit. That's something I have to protect. That's 500,000 of them. So that's a bit of the scale we're talking about. Yeah. 1.1 petabytes of RAM being used. So what type of log collection are you talking about when you've got 500,000 containers? So we do centralized collection of our critical security logs, such as CloudTrail, GCP audit logs, Azure audit logs. You centrally collect those because those are all coming direct from the cloud provider anyway. Authentication logging, all of your admin console type logging, that all gets centrally located in a single cluster. Within each cloud region, from the previous slide you saw, we have 60 different cloud regions across 3 different cloud providers. Each cloud region, we keep the logs within the region. We have an Elasticsearch cluster within every single region that collects the logs. They collect the observability logs, and I like to call them observability logs because that means I don't have to pay for them out of my budget. They come out of the observability budget. We're talking about like CPU monitoring, uptime monitoring, all of this stuff that the ops team needs to make sure that everything's running perfectly fine inside the cloud. But that also includes the proxy logs, your NetFlow logs, your audit beat logs, your authentication logs. All of that stuff is observability and security data. It's both. And so all of that data stays within each regional cluster, and then we use cross-cluster search to search from it from a central location. Why do we do that? Because we have 500 terabytes per day of logs being created. If you were to ship 500 terabytes a day to a central server, that's $40,000 per day just for shipping. That's not even counting the storage and all the other overhead that would come in from duplicating your logs. And so keep the logs where they were created, don't ship them out of the cluster. And with cross-cluster search, the query gets distributed out, and then the responses come back. And so that is absolutely critical for saving money and for the speed of it, because now we have 60 clusters distributed running our queries. We can, so for an example, when log4shell happened, we were looking for JNDI strings in everything. And when we were running these queries over the last 7 days of data, which is what we keep in our hot storage on our SSDs, we would get the responses in about 30 seconds. And so you're talking over 7 days of data, that's about 3 petabytes of data, and we'd get responses in 30 to 40 seconds because it's being distributed amongst 60 different clusters. Challenge, the speed of the attacks. If you can write a script to create and tear down infrastructure within your cloud, then so can an attacker. And if you think about how, this is what everybody loves about the cloud, and this is why businesses are all moving to the cloud, because you can automatically provision and deprovision and do all of these cool things, but if you can do it, so can the attacker. You don't have time to do on-disk forensics. You don't have time to setgrep awk your way through logs. You don't have time when an attack is happening to do memory forensics or all of these traditional forensics things. It just doesn't exist. You've got to move at the attacker's speed, and you've got to plan for that before the attack happens. And then the final challenge, the complexity of the cloud. Infrastructure as code is magical when you see it in action, but it's also scary when you see like what's happening on the back end, and when it breaks, some wizard has to come in and fix the magic. Do you know how it works? Does anybody in your organization really know how all of this stuff works? There's a lot going on. One of the cool infrastructure as code magic moments that I had recently, so at Elastic, our InfoSec team, we run all of our production clusters on the most recent release of Elasticsearch, and we update within 12 hours of the release. And so, I'm sure some of you think about that for a second. All of our production clusters are completely upgraded within 12 hours of the release happening. And the way they do that now, they've got this whole pipeline set up using Argo and Kubernetes. They go into GitHub, they make a pull request where they take one file and they change the version number. And it's a pull request where it just goes 8.8 to 8.9. And then when somebody approves that pull request, all this magic happens on the back end, and 18 clusters get upgraded, and within about an hour, they're all running the newest version. How does that happen? Magic. So this is a very simplified version of the cloud. How do these interact? How do they work? How does authentication work? These, as a detection engineer, if your job is to protect these cloud services, you need to try to work through and understand this. Read the documentation, because I tell you what, the red team, I know this for a fact, they are reading the documentation. They told us that. They will figure out exactly how things work. You see all these lines. Every single line is a trust that's happening. And so we've got over here, okay, HashiCorp and GitHub. We use MFA authentication. You got to use your fingerprint. We're good, right? No, not really, because once you get past that point, once you're inside the cloud and inside the plumbing, everything is just a token. And what is a token? It's a string of text. That's it. It always is. And they're used everywhere. They're used in API calls and used to authenticate. Every single one of those blue lines represents a trust of some sort that this little string of text you gave me is good to go. And so if you want to get into AWS as an attacker and deploy lots of infrastructure, well, maybe you've got access to Jenkins, and Jenkins can talk to Terraform, and Terraform trusts Jenkins. And then AWS doesn't trust Jenkins, but they trust Terraform. And you've got this chain of trust going along that the attacker is going to exploit. And then in the end, the cloud, you've got something connected to the internet. And for us, it's customer controlled. We don't even control it. So they can, do what they want with it. So we have to kind of, then protect against that. So after I, scare you with all of that, talk about all the challenges and everything like that, how do you actually detect real-world attacks? What we like to do is we sit down and we face our fears inside our detection team. You say, what keeps me up at night? What am I afraid of and why? And then how would an attacker achieve that? And use, I've got 10 years of red team experience, so I kind of use that to say, oh, I would attack this by doing this, this, and then this. And we say, okay, cool, now how do we catch that? And so the three biggest fears when it comes to the cloud, for me, it's exploitable services, misconfigurations, and compromised tokens. Exploitable service, we're talking about anything such as log4shell, some sort of zero-day. We have a lot of internet-connected, internet-facing services. Log4shell showed us that it's not just the services that are connected to the internet. We have to be worried about everything that handles untrusted data in any way. Any process that handles user-controlled data can be vulnerable. Crazy story with Log4shell, when that happened, we were all, we were looking at our data. Because we have visibility, we can track these strings as they progress through our infrastructure. And we've got a bug bounty program, and somebody said, hey, I submitted this attack string in this thing that you own, and I got a shell that called back. And so we looked at it, and we said, okay, here's the string. And we followed over here. There's no execution. Followed over here, no execution. Followed over here, it gets passed off to the AWS backend service. And then the execution is happening on AWS's servers. And so it wasn't even our servers that were getting exploited at that point. This was within like an hour of the attack getting posted. And so this is kind of comes into that speed of the attacks. Within an hour of it going public, they found a way. They didn't even know they found a way. They were exploiting AWS backend. We just paid the bounty and told AWS it was fixed within minutes. But it was just one of those things when Log4shell was going, you can't trust anything. And so how do you detect that from a detection engineering point of view? Exploiting that process is only the first step. As I said, that was some back-end AWS process, but the attacker knew that it was exploited because they got a connection outbound. So how do you detect this? You detect it's your cloud. It may be complex, it may be a challenge, but it's your cloud. You know what runs here, and the great thing about the cloud is it's almost entirely programmatically controlled. So you can detect strange child processes, strange network connections, service accounts doing things that they never do before. The Apache server or the Apache user account only should run a very small set of processes. If you ever see it running anything else, trigger an alert. We've caught actual 0 days. As I said, we have a bug bounty program. We've had people find 0 days in Kibana, and we've detected it before they submitted the bug bounty. Because we saw that that Kibana was spawning child processes that it shouldn't be spawning. Here's an example. I don't know of any 0 days in NGINX right now, but it could be some later. And this is kind of just talking about the methodology to build these detection rules. So you start out by saying, okay, NGINX takes data, untrusted data from the internet. Let me go do a search for everything where NGINX is the parent process. And then I start to tune it out and get rid of the known goods. And so from this, I can say, okay, NGINX, from my query, I saw that it spawns itself all the time because it's handling load balancing, it forks itself a lot. So I'm going to filter that out. And then I see that when NGINX gets run to do an upgrade, it spawns lots of strange child processes. But if I filter those two events out, now I get 0 results. So I have a detection that's pretty solid to say, hey, if I ever see NGINX spawning curl or bash or anything like that, fire an alert. It just got exploited. I just detected a 0 day. Yay me. Strange curl or wget processes. These are also absolutely key. These are noisy. These are hard to tune because everybody loves to use curl. Everybody loves to use wget. You're going to see it a lot in your environment, but it's absolutely worth the work. Like I said, we saw the attackers, when they were attacking the Node4shell, they would often run curl or wget as a way to get back out and talk to their infrastructure. And so when you see processes executing wget or curl that have never executed it before, fire an alert. Misconfigurations, another big fear inside the cloud. So what do I mean by misconfigurations? Everybody's favorite, an S3 bucket plugged into the world with a sensitive data, credit card information, PII, everybody's least favorite incident to work. And this also includes overprivileged accounts, automation's gone wrong, all of these different things. Containers so maybe somebody spins up a container and then they just forget about it, and now you've got a container that never gets patched, never gets updated, and 3 years later it's sitting on the internet, vulnerable to attacks. These are all misconfigurations. Luckily, luckily for detection engineers and for me especially, there are a lot of pre-built detections for these types of things. Justin's team and Elastic, we've got a ton of pre-built detections to say, okay, S3 buckets exposed to the world, misconfigurations. Take them, turn them on, use them. You absolutely want to track these down before somebody else finds them. Something new, our product team, somebody actually was on our InfoSec team and then he left and now he's building this out to sell to people. The cloud security posture where you can basically run you point it at your AWS account or GCP or Azure, it ingests all the information and then it makes pretty graphs to show management about all of the risks and all of the misconfigurations inside of your cloud. And we've got this for Kubernetes as well. You absolutely want to track these misconfigurations down before they become a problem. And now we're kind of getting on to my biggest fear, compromised tokens. Get a drink. When I'm talking about tokens, I'm talking AWS secret keys, GitHub PATs, all of these different ways that a machine authenticates to another machine. Do you know how your tokens are stored? Are you really sure? How are they being used? Because when you start hunting around inside of your environment, you'll probably find them all over the place. I definitely recommend something like TruffleHog or any of these systems to go search through Slack, search through your email, your your documents, your file servers. People share these things. They get posted in, people will post logs from when they're troubleshooting things, and they'll contain these tokens. They're everywhere. It's a huge pain in the butt. Monitor paste in for anything that looks like your stuff. There are services out there that's absolutely worth it. These things are everywhere, and they're a huge pain in the butt to keep track of. And so they're also one of the most challenging things from a detection engineering point of view to detect. Because when you have a cloud token, like an AWS secret key, the attacker can take that key and then go use it from their own infrastructure. Now I don't have endpoint logs. I don't have proxy logs. I don't have anything. They're just talking directly to AWS. So maybe I have some CloudTrail logs, but that's it. There's nothing else. And it just says, hey, there was a successful authentication with this token, which we see thousands of times a day from all over the world because we've got 60 different cloud regions. And it's very challenging to detect, especially if the attacker is being sneaky and they're not being, sometimes you get those crypto attackers where they just attack and within seconds they spin up crypto miners on all your VMs. Great, thanks. So how do you detect a compromised token? And so when you think about what the attacker does with the token, like I said, they immediately go off to their own infrastructure and start using it. That's what we're going to attack, or that's what we're going to detect. And so how do I detect a token not being used on my own infrastructure? Well, I've got my assets. I've got my asset database. I've got all my information in the SIEM. So my endpoints from my workstations, they all go through a proxy. So I've got the IP addresses that my endpoints work. So this workstation, it connects to from Troopers. Now the Troopers IP address is going to show up in my proxy from my workstation. So we can say, hey, Aaron was working from here today, so that's a known good IP address. And so we can say, if a token was used anywhere else, fire an alert. And it's a pretty complex system that I'm going to get into, but this took our SIEM engine, our SOAR system, and our asset database to build. But this is definitely worthwhile, and it's really showing dividends with this. And so, like I said, any API activity, and it's not just API activity, but like GitHub PATs, MFA authentication, or authentications via service accounts that you've given MFA exemptions to, SSH logins, all of this stuff. So, how do you detect an SSH login, for example, from a system that you don't own? Well, the first step, we have to detect that activity. And so we use a new terms rule to say, okay, if this IP address hasn't been seen in the last 30 days, fire an alert. And so in this example, I'm looking at git clone and git fetch from a private repo. And so this is somebody with access to a private repo in GitHub, which means that they have either logged in via MFA or they have a personal access token. So at this point, we want to take this and we get it out of our SIEM we use an action here to send it to our SOAR system, which we use Tines for this. But this is just a webhook, and you can send it to however you're doing it. That fancy little not-so-JSON at the bottom, that will take the entire contents of your alert, format it as JSON, and then send that off to your webhook. And so then you'll have all of the fields from your alert ready to go for whatever soaring you want to do. And so this is the workflow that we've just developed in order to detect these rules. And so I'll kind of go over this a bit. So you got the webhook at the top, and then we just run a string of HTTP requests back to different clusters. And so we say, hey, is this IP address in our asset database? Yes or no? Is this in our ADR proxy? Do we have an endpoint on this? Is this one of our workstations that we manage and protect? Then we look in FileBeat, because what you find out very quickly is that you've got all these third-party serverless automation systems like GitHub Actions or Lambda functions in AWS that you don't have an agent on, but you've given it authority to do actions on your system. And so we use FileBeat to eliminate those IP addresses. And then we look in our Okta logs, and I look for a successful MFA login in the last 24 hours from that IP using a fingerprint or YubiKey or something of that nature, of course. And then after all that, I go over here and I say, okay, if this source IP was found in any of those queries, go back to the SIEM and close the alert. And so now we've got these alerts. This is great for your metrics, by the way. If you want to show this to your CISO, this is great, because now you can have hundreds of alerts come in, and within seconds, they get closed. They get triaged automatically and then closed out. We sleep for 5 minutes, and then I go back and I say, hey, is that alert still open? And if it's open, now I send it to Slack with all that enrichment. And depending on your SLAs, if you're an MSP or things like that, say you've got to respond to certain alerts within a certain amount of time. It's that worker in Japan and you're waiting for the guy in Germany to wake up. Then maybe you sleep for 2 hours and you say, hey, nobody's acknowledged this alert. Now I'm getting on pager duty and I'm calling you in the middle of the night. Like I said, this is all configurable. This is Tines we use because it's easy and we don't have the resources for a full-time person dedicated to maintaining our automation. Our team, we have 2 detection engineers and 4 incident responders. And 1 person who was on the incident response and is now building automations full-time. So yeah, we're a small team, so we automate everything. This bottom bullet here, if you build this in your environment, the first 2 months or so that you have this, all you're going to do is respond to shadow IT alerts. And what do I mean by shadow IT? It's systems that you own, but nobody's told you about. It's not in your asset database. Somebody stood up a server and they didn't put an endpoint on it. Somebody got a new laptop and they forgot to put the AV and your EDR system on it. Or maybe the EDR broke on this laptop because it's 8 years old and it's time to get this new user a laptop. This is amazing at finding shadow IT, which is a different problem, but also a problem that needs to be solved. But once you kind of work through the shadow IT stuff, then at that point you should only see alerts when somebody's using these tokens from untrusted IP address space. So here's just some additional resources. I've written a lot of blog posts on Elastic about how we've built a lot of these things. As I said, I'm an InfoSec real-world detection engineer. It's not my job to get out and market things, but I like to anyway. Most of the blog posts are written by the first 2 types of detection engineers because it's marketing and it's great for their company. And so we need more people that are on the real-world side doing the job day in, day out, getting out to the community like this and talking about the challenges we face and how we've overcome them. So that's right at 50 minutes. Any questions? Thank you. And yes, this is the never-ending story. That is detection engineering.
Yeah. Thank you very much. Very, very interesting. So, as you've asked, any questions?
Thank you for the talk.
You're welcome.
I just have a small question regarding keeping the logs where they are, which you stated. Obviously, you would want to keep them on the same cluster, but you surely are going to extract them out of the containers and centralize them, aren't you?
Yes, we're within each cloud region. We use either FileBeat or AuditBeat or sometimes the new integrations to take the logs from the containers themselves and then ship them into that local regional logging cluster. And then we keep the logs inside the regional logging clusters. We have 7 days of hot data, which is SSD storage. And then after that, we move right to frozen storage, which is still searchable, but that's like S3 bucket type storage, which is way, way cheaper. And so the 7 days of data I can run queries on, and it'll respond within like 20 to 30 seconds. If I get into that frozen data, that's usually because a lawyer's asked for us to do it. That will take minutes to hours sometimes to return because it's just a lot slower.
Anyone else?
There's one back there.
Oh.
Yeah, thank you. So you talked a lot about trust and trusting all these different tools and these environments where it feels like a huge forest. Do you also do some like baselining and validation of those tools, saying, okay, now we have some input, we know how it looks like, and those tools produce the output and you validate it? Because it could happen that you like put in some traffic or whatever in, and you would expect to have like, you put it 10 events in, but you only see 9 events, and then you think, okay, there's something wrong with this tool. I trust, I think it's working correctly, but do you do some additional like validation QA for this stuff that you know that you can trust the tools?
Yeah, yes, we have a pretty solid log onboarding process for all of these different technologies. Our cloud environment is certified with all sorts of certifications, PCI, FedRAMP, all these things. And so it's pretty solidly controlled, and we've documented a lot of that stuff. And but yeah, there's absolutely new technologies where we get it, and then we say these logs are crap. We're like, what is this? And then we have to work with the vendor or work with maybe the people collecting the logs to say, hey, how can we improve this? Or the fidelity is just not there. Or we can say, hey, this trusts this, but it shouldn't. So maybe we need to lock that down. And so that's all a big input cycle, or it's that constant never-ending story.
Anyone else?
Hey, thank you for the talk.
Yep.
I assume you use Elastic Seam, right?
Yeah.
And Elastic Seam has a ML stack that does this, I don't know, anomaly logic. You describe a lot of manual heuristics, but do you use yourself the ML stack for, I don't know, some anomaly triggers? And if you use, how, in what pipeline? Like, do you treat them directly, or you like parse like with some meta logic on top?
Yeah, so we use the machine learning. Mostly we use the out-of-the-box detection alerts that Justin's team's created. We've got a few custom rules. For the cloud, we have a lot of custom rules. The machine learning in the cloud is amazing for finding humans. And so, like I said, the cloud is very automated. It's very machines talking to other machines. And so what we found, that as soon as a human being logs into a system, it triggers lots of alerts on our side, which is good and bad, because it's usually just somebody troubleshooting something or applying an update. But if you look for like rare processes by username, rare processes by host name, another good one that we found in the cloud environments is rare error codes. So like in your AWS logs, here's an error code that we've never seen before. Send an alert, whether that's our problem or an operational problem, and somebody needs to look at it.
Any additional questions? All right, then. Thank you very much again, Aaron.
Thank you for having me.